Most modern yo-yos are made up of two body halves, two external weight rings, a central steel ball bearing, and some form of axle system using a threaded screw and two hex nuts. Yo-yos have changed in function, shape, and performance over the last century. This older yo-yo, such as this imperial-shaped yo-yo, has a traditional shape with the rounded edges on the outside of the yo-yo. This shape has the most of its mass concentrated closer to the bearing of the yo-yo. This butterfly-shaped yo-yo is like the traditional yo-yo but flipped around. The mass is concentrated away from the bearing, so this shape spins for a longer time. The modern butterfly has the addition of weight rings to increase the width and optimize mass distribution away from the center of the yo-yo. Inertia is a property of matter that can be described as matter being lazy. Inertia is the tendency for an object to keep doing what it's doing, whether that be sitting on a shelf or spinning at high speeds. Different shapes have different inertias. For example, a ring uses the formula I equals mr squared, with m being the mass and r being the radius of the ring. By looking at the formula, an increase in the mass or the ring's radius will increase the inertia, therefore making the yo-yo spin longer. A disk, however, uses the formula I equals 1/2 mr squared. This means that a disk has half the inertia as a ring of the same mass and radius. With this in mind, a yo-yo should be composed of more rings and less disks for the longest spin time to be achieved. This is an example of distribution of mass. The rings are placed as far out from the center as possible to add inertia and therefore add stability. Here you can see a generalization about how rings and disks form a yo-yo. The yo-yo has a ring on the outside to give it more inertia away from the center. This yo-yo has an entirely new shape that is engineered to have more rings than disks. If the yo-yo is turned sideways, you can see that the weight rings make up another ring, to which the I equals mr squared formula applies. To increase the inertia here, the yo-yo can be made wider to increase the ring's radius. As you may have noticed, the yo-yo's mass is rarely increased. This is because there is another side to engineering yo-yos that most scientists would not consider. A competitive yo-yo player would not use a yo-yo that is too big and heavy, which is why the changes are made to the width and shape. Players want a yo-yo to be quick as well as long spinning. This new shape is the perfect combination of physics and design with increased inertia.